Hi, welcome to Project Geospatial. I'm Adam Simmons, and I have the pleasure of coming back to a awesome company that is focused on synthetic data, Rendered.AI. And here with me to talk about synthetic data is Chris Andrews. Chris, can you go ahead and give an introduction to yourself and how you got started in the industry?
Sure, and thank you very much for hosting me, Adam. It's been great to be in touch with you over the last couple of years, and we really appreciated the previous episode that you did on us. So my background is pretty heavily in the geospatial industry. I actually built my own kind of GIS for my master's work back in the '90s, and then I knew somebody who had been through one of the early GIS programs at SUNY Buffalo, and she basically saw what I did and said, "Hey, you'd be perfect for this GIS stuff." And so I ended up teaching myself GIS, starting with ArcView 2 and programming on Avenue back in the '90s in college, and then I actually taught the first GIS classes at the University of Rochester, where I went. After graduating, I ended up having programming skills and GIS skills, which were far more valuable than ecology and evolutionary biology degrees back then. And so that ended up getting me into startups. I went through a couple small startups that didn't pan out, and then I ended up in enterprise consulting. First at the Kennedy Space Center, working on a base-wide GIS, and then later in the utilities industry, real property, and a couple other industries, mostly working with large project-oriented consulting firms like Idea Integration and a company that used to be called MWH Global. But I got a ton of exposure to everything from Oracle, uh, Java, enterprise bus tech to a ton of database programming, all kinds of stuff that evolved around all different types of GIS applications and integration. I ended up wanting to change my career around and started writing articles. And then, ironically, that actually is what got me into Autodesk a couple years later. And I ended up going into Autodesk as first on a business development team, and then I literally got hijacked to be a product manager on their 3D digital cities effort. That is where I really got a start in the intersection of 3D and geospatial. And it was very early. That was 2008. There were a lot of topics that were in discussion, such as reality capture, the whole concept that you could kind of cook 3D buildings for a city from satellite imagery was actually being done then at a very low res kind of level by folks like Kobe and the French government. I got to meet and work with a bunch of different folks like that, but it definitely started to get me steeped into the combination of that reality capture, snapshot, 3D modeling of the real world, along with procedural data and kind of synthetic generation of content to also populate digital cities. I personally have built a couple L systems generators. We acquired a company called 3D Geo when I was with Autodesk. And then later, when I went to Esri, underneath me was also a product that's still out there, and that is a procedural generator called City Engine that I'm sure some of your listeners have heard of. Um, I was at Autodesk for about 7 years, mostly in the infrastructure group. I did a brief stunt doing a 3D visualization startup for them in the life sciences, actually. And then I spent about 18 months in their film and game group as well. After leaving Geospatial, I decided I wanted to get back into it. And so after a little bit, I ended up at Esri as their 3D product manager. I started off as an individual contributor there. And then after 7 years there, I was one of their four product management leads. I had about 20 product managers under me. We had around 45 products covering somewhere around 45 to 50 million in direct revenue, and then a whole lot more in indirect. And that included, I helped get ArcGIS Earth started. I worked with Theo Azalopoulos at Autodesk to get the Autodesk Esri partnership started, and that led to a bunch of product development, including GeoBorn, a product that is actually going really well out there now. I helped participate in writing some of the specs for I3S, the 3D 3D streaming format that Esri has offered, and that's now gone through OGC. And and so you can see there's been a couple common threads in that. I touched a lot of real world domains, a lot of geospatial stuff, a lot of 3D in different shapes. 3D for like regular users who could care less what the technology is underneath, but also 3D for some deep experts. And after that whole career arc, I decided I wanted to get back to smaller companies where I had a bit more direct input into the success or failure of the company. And I interviewed with a variety of small startups and ended up landing with Nathan Quinces, the CEO and primary founder of Rendered.AI. And what I loved about his pitch was that he was talking about a couple things that were really appealing to me. Uh, a new application of technology in an existing domain in a way that has the opportunity to explode and be used widely across that domain, and then technology that also actually solves real or helps people solve real business problems. Like I said, I spent a little bit of time in film and game. I like film and game. I like to play them, but working on film and game tech directly doesn't really drive me. But helping customers solve real problems that make a difference in their daily life in terms of whether their business is going to be successful or not, that really does drive me quite a lot. So, so I got this great pitch about synthetic data and the opportunity to create fake data to help train computer vision models from Nathan. And at first, I kind of walked away from that first conversation thinking, this seems kind of fantastical. But the more that I thought about it, and a couple other follow up calls, it convinced me that it was absolutely the kind of opportunity that I was looking for. And I've been with the company for 18 months, and it's been fantastic.
Well, thanks for that overview. So, getting into it a little bit, can you talk about, give us a definition of what synthetic data actually is? It's a broad term, but for our industry, it means something very specific.
Yes, that's right. So when I talk about synthetic data, as I just referenced a little bit in my career arc, I've had exposure with a variety of different types of synthetic content or computer generated or computer derived content that can be used for a whole bunch of different purposes. When I say synthetic data, I'm talking about engineered, generated, simulated data with annotation and metadata specifically used to train or validate or test machine learning and artificial intelligence algorithms. So synthetic data for me is not just a single model or a single, a single scene in 3D. It's actually a synthetic data set is a file folder or zip file or maybe a full drive full of training image chips that were all generated out of some kind of digital process, typically some kind of rendering system, and that is using a 3D scene and 3D assets, and then other 3D tools and techniques to specifically output a desired set of pixels that match the characteristics of real sensor data, and that also are spit out with labels, annotation, to be able to tell you exactly what is at which pixel in each image. And these data sets that I'm talking about can range from 100 images to 10,000 images to even many more.
I
We
think that's the key right there, right? So we kind of, to take it another level up, you are literally generating artificial overhead, satellite, or aerial imagery in different sensor modes, correct?
That's right. That's right. The fundamental problem that we are trying to address is that today, if you approach most people in the computer vision market today, most people in the machine learning, the whole data science realm today, typically start off using real data sets in the structured data space, the form field data, like the forms that you fill in online, there there is potential application of certain types of synthetic data, but I'm going to stay away from that today. We typically focus on the unstructured space. So all of that sensor data that is being collected from out in space, you can talk about satellites looking at Earth. You can talk about different types of sensors looking at the Earth, radar sensors, hyperspectral, multispectral, RGB, panchromatic. You can also even talk about satellites looking at other satellites and satellites looking at other parts of the solar system. Um, then to aerial imagery, to truck mounted, boat mounted, backpack mounted. And then you can even talk about computer vision content being things like microscope video. So actually at Rendered, we focus on unstructured synthetic data, and we actually provide a platform and technology that can be applied to just about any type of computer vision synthetic content. Our customers are typically trying to apply computer vision to some real sensor domain, and they're running into one of several common problems are experienced when you're working with real sensor data. Labeling existing sensor data can be very expensive and inaccurate, and in fact, in some cases, can be almost impossible. Sometimes humans are actually really bad at looking at things like hyperspectral imagery or radar imagery and then interpreting that accurately for labeling. Um, in some cases, real data may have privacy constraints or other security constraints that make it hard to get. Um, in many cases, folks who are typically used to only working with real data sets are in their heads, they're just focusing on scraping together whatever data they can get their hands on to try to push through algorithms and training processes. So
So
when it
it's not
comes
just
to
a pricing issue. It's also about it's also just plain acquiring the data could be a hassle in a lot of different mediums. So even the business model of acquiring imagery is well, it's tedious, it's painful. But then you also have the issue with machine learning that you need a lot of it, the scaling issue. I need a ton of data in this one type of sensor. It's not just expensive, but I need so much that the traditional platforms, the traditional providers do not know how to give it to me for my use case, right?
that is that is definitely the case. If you look at especially things like rare and unusual objects or scenarios of unusual objects, so it may not matter so much that you see a tanker ship or a gasoline fueling truck in a particular piece of imagery, but it may be very important when that fueling truck is next to another truck of a specific type. Capturing, getting enough data samples to train an algorithm to recognize those types of trucks in that specific scenario can be extremely costly. And for some types of imagery, you may be talking $1,000 an image. So if you need hundreds or thousands to train an algorithm, that gets really expensive very fast. And so if you can simulate imagery of whatever type you want, whether it's SAR or hyperspectral or just plain old RGB satellite at various resolutions, then conceivably you could generate very large data sets with these kind of scenarios. So, perfect, not quite perfect or idealized is not the right word, but with the scenarios that you're actually looking for, and then use synthetic data to train algorithms. In some cases, that may be good enough. Enough. In other cases, what you may be doing is training an algorithm to sift through a library of existing images to find more examples that a human couldn't find when they were looking through thousands and thousands of images. So yeah,
Well,
it's
that,
not just. Right. Go ahead.
that naturally brings to forth a couple different questions, right? So first of all, what's the level of effort to get this data generated? Let's say a customer comes with a requirement like, "Hey, I need 1,000 images based off of this type of object." So what's the level of effort to generate that and the timeline? And then part two And is uh, what is the what's the level of quality? Because I think there is a stigma behind, if it's simulated, there has to be some kind of catch. Is it too biased towards the simulated data, or can it actually look for real world objects based off of this training data? And so there's questions in the quality too, right? Can you talk about that in terms of demystifying some of these questions for our audience?
Yeah. So, and there are a couple different aspects to that question. One is, and we get this question a lot, is how do we know that our data is good quality? And that's kind of an amusing question in itself, because in some cases, customers actually want bad quality data. One example is a customer in the defense realm looking at remote sensing imagery used synthetic data to demonstrate that they could that they use synthetic data from Rendered to demonstrate that they could train to look for objects in a specific type of imagery, and then they wanted to also demonstrate that if they did something absurd in that generated imagery, that their algorithms would correctly fail as they expected. And so in that particular case, they took a color modifier and they painted every one of their objects of interest yellow. And you would never see these objects be yellow in the real world, but they were really happy because what happened was their algorithm correctly performed on real data and synthetic data when applied to objects that you'd expect it to find. And then when they applied the algorithm at the canary yellow objects, it failed. Um, the process to sorry, the process to get started with synthetic data is sometimes more considered than a lot of customers at first believe it will be. We do often get folks coming to us just saying, "Can we get 1,000 images from you, or 500, or 10,000?" In reality, we've seen that approach almost always fails. So we could generate 1,000 images for a variety of different scenarios that we might have, different types of prior art for synthetic data channels, everything from DeerSig, which is a physically accurate simulator maintained by RIT, to our own SAR simulator, to RGB satellite imagery. We could generate conceivably image chips for a customer and just hand them over. But what happens is customers who are asking for those image chips are typically still in the mindset of, I'm just going to scrape together whatever I can get and then see how it works, real data or synthetic data. The opportunity with synthetic data is that you can change it. So you can try something and then maybe it doesn't quite work. And maybe you have some ideas why. And we actually give folks some tools for helping investigate differences in data sets. And so then maybe you can actually make some changes to the generated data and get another data set and then test that and see if it works better. And if so, keep going until you actually achieve a desired level of performance that fits your problem set. Synthetic data generation is not a one step process. It is typically an iterative process that requires feedback between data scientists and the folks who are doing the simulation modeling or scenario generation. That is actually the kind of the heart of the synthetic data creation pipeline. So it's not as simple as just coming to us and asking for data. Our platform is built upon the idea that we actually provide a platform that does compute management, job management, team collaboration. And then on top of that platform, you deploy these containerized simulations. Each simulation is called a synthetic data channel. And that synthetic data channel basically is the universe of variation and parameterization that you need to develop to generate a variety of data sets that allow you to train and test the algorithms that you're working on.
No, thank you. So, getting into it a little bit even further, can you talk about some more details about the quality of the data? Obviously, things have improved, but it is a question you get all the time. Can you how accurate is synthetic data? Can you talk to me about that a little bit? And of course, I understand you're also coming from a bit of a biased perspective on that too. As uh, but but I'm sure you understand. Obviously, the data is as good as you design it to be, but to some extent, um, people have a lot of concerns about it, right? So,
Yeah, we've so it's so tough to say what's the quality, because the quality is determined by, at one level, by your success in meeting your training objectives, and training objectives can vary very widely between customer scenarios. One, for example, we have a whole set of customers who come to us who don't even have a sensor deployed in the field. Think about companies that are putting up future satellites. So one example that's been publicly disclosed is Planet. And Planet is using us to generate synthetic hyperspectral images in anticipation of their future satellite launches. And the quality is high, in the sense that we actually work with a third party, Riverside Research, who has vetted that the synthetic data is physically accurate. We're using DIRSIG, this high quality U.S. government supported physically accurate render, and we're outputting imagery, multi-channel hyperspectral images, these massive multi-channel TIFFs that that are effectively what Planet will be getting off of a satellite.
I and that's a very great use case. It's more of a general approach to say, here's some examples of what our sensor could potentially look like before it launches. I
Right.
think the more folks who are more skeptical of it has to go with, hey, I want to simulate, I want to create machine learning algorithm on just making cars. Can you accurately simulate satellite imagery that accurate looks like a bunch of cars are on the ground, for example? And obviously, that could be synonymous for nearly any generic object, um,
Yeah.
but something like that.
Yes, the original server that helped get a lot of our platform efforts started is with Orbital Insight, and the NGA, and the original project there was actually attempting to improve algorithms to identify difficult to label objects like construction cranes in the XView data set, which is a real satellite imagery data set. That project, the phase one of that server, actually used r- rendered AI to generate synthetic imagery, and they were able to demonstrate that they were able to not only detect construction cranes and a couple other unusual objects with very high increase the precision of detection. They also were able to show that they were able to train algorithms with far fewer images than they required if they were using only real images. We we have had numerous customers achieve their training objectives using synthetic satellite imagery generated out of rendered, much of which was based upon some of the initial technology that was used to do the orbital project. That orbital NGA project has been continued. We've been working on this phase two for the last year and a half, and we absolutely see a variety of paths that customers are taking. If they can't get any data and what they're looking for is warm hits, then they can use purely synthetic data sets out of rendered. In some cases, they may post-process them to make them even more like real data. We provide the ability to do what's called style transfer or domain adaptation using a cyclogram. So you can train a cyclogram algorithm on real data sets that are similar to what you'll be looking for. Then you can generate synthetic data sets, render them out of rendered, and then in our system, you can actually apply the cyclogram to make the simulated data look even more like the real data to an AI. Um, For other customers who maybe already are achieving some level of performance in a scenario, they may actually end up using a mix of both synthetic and real data to kind of incrementally improve the algorithms that the algorithm performance that they're training. Uh, I can say we've had repeat business. We've also had cases where, in one case, a customer in a hurry used us to generate oblique marine imagery looking for distant objects. And they were so successful with only synthetic data that they actually terminated their subscription early, which is not something that was great for us on one level, but it was fantastic for us on the level that we were sure we could help them. And they really had a hard time getting real data ahead of the exercise they were participating in, and they were able to use it. And on day one of the exercise, demonstrated that they had achieved a level of detection with synthetic data only that exceeded the initial requirements that they had. So it's the quality of the data. We've seen some cases where the quality is extremely high in the sense that we've met the training objectives. In many cases, the imagery, and I'll share some with you. The imagery can look just like a photo to the human eye. The trick is, it doesn't really matter what a human thinks. It's what does an algorithm think, right? So the the important nuance of synthetic data is that it needs to be successful for the algorithm training or validation process that's being done on that data. And some of our customers do get a little bit stuck on that. They they may think that they have a specific uh, uh, they may think they may be able to judge the quality of data, but data quality can be really interestingly subtle. One example is what we had one partner use Rendered to introduce variation in synthetic imagery. And one type of variation they introduced is called pose variation. So they were changing the camera angle looking at the object of interest, which is a manufactured part in this case. And later they realized that in their real world system, there is no pose variation. So they'd actually degraded the quality of the synthetic data, not from a look and feel perspective, but by introducing a type of variability that doesn't actually exist in the real system that they're monitoring. So if I hedge a little bit on data quality, it's because data quality means many different things to many different people and can be,
Absolutely. But, I think the point was, can it fool another human's eyes? Yeah, I think your initial question was, or your answer was yes. Can it be used to train an algorithm successfully on objects that someone's looking for? I think you've also demonstrated that answer is also yes. So we've come a long way from just this being conceptual. Even in the beginning of the company, you've had a lot of success, but even then, you were having a lot of lessons learned, even a couple of years later, even today. Which actually brings me to my next question: is how has the technology changed over the last couple of years to improve and get things better? And maybe you want to also touch on how you are not focused on generative AI, right?
Yep. I can definitely address that. Uh, the the technology that Rendered uses is fundamentally technology that started back in the late 70s and the 80s, right? It started out with early 3D rendering and modeling technology. And that has come a huge way and has actually improved exponentially in just the last couple of years. So we may use a renderer, including things like Blender, an open source package, or our own SAR simulator is our own rendering system. DeerSig is another one. NVIDIA Omniverse, we're an NVIDIA consumption partner. All of these technologies have had investment that have greatly been able to do things like take advantage of modern GPUs and job parallelization. You can a lot of 3D rendering is multiple passes across the same scene, and in the old days, those passes were stacked up sequentially, and these days you don't have to do that synchronous processing. You can so there's a lot more that can be done in the same amount of time in terms of basically generating pixels that emulate the pixels that would be captured from a real world sensor. That is ultimately what we're trying to do. And so the technologies to enable us to do that today are far beyond where they were even just a couple of years ago. Um, we also are benefiting tremendously from cloud compute, cloud capabilities. One of the value props of Rendered is that we can mask some of the complexity that someone would have to take on if they were to set up their own rendering farm and compute management system in the cloud. We work almost exclusively with Amazon and AWS, and um, we have benefited tremendously from changes that Amazon has made to enable you to spin up different types of instances, increasing the size of instances and increasing access to GPUs. And even, for example, we're hoping to work more with NVIDIA and Amazon together in the near future around the fact that there are now Omniverse GPU uh, capable instances available in Amazon. So it's really great to see some of these big technology companies are coming together to provide combined offerings that are going to enable even more. We are seeing some interesting changes in the market and very recently. The explosion around conversational AI, generative AI, diffusion models has really changed the conversation with some customers. I'd say even a year ago, we were more often having to explain what synthetic data was from a very first principles level, right? It's fake data that is designed to be physically accurate. That conversation has decreased to some extent because many people now have heard of synthetic content or synthetic data, but they immediately jump to the idea that, oh well, then we must be using stable diffusion or some kind of generative AI technology to generate synthetic data. In fact, that's a little misleading. We don't use diffusion models or other generative techniques, generative AI techniques, to directly generate every image chip that comes out of Rendered. Unfortunately, when you use most of those technologies today, you do not know what is at which pixel in the image. So you may be able to feed an algorithm a description looking for an elephant standing in the grass in front of a tree with a blue sky, and you may get 1,000 pictures of elephants standing in the grass with trees and blue sky, but you actually have there's no pixel level labeling that is possible today on that type of imagery. You're also not guaranteed that your elephant is actually anatomically correct to an algorithm. The elephant may look pretty darn good to a human, uh, but and the elephant is the derived uh, output of an interpolated uh, and yeah, it's basically process that changes pixels around until the pixels end up fitting into this probability space that says that yeah that there's a very high probability that this particular combination of pixels represents elephant, ground, grass, tree, and sky. But there's no ability to go in and define bounding boxes or specific pixel masks, so it's that you know exactly what is where in each image. That is a key value of what we do in terms of simulator generated data, synthetic data for AI training with Rendered, you actually know exactly where each object is, where all the classifications are. If you're doing, say, classifying generated crops, has simulated crops in synthetic imagery. Um, so we are seeing quite a bit of new tech start to be talked about in the market, and some of that tech is actually more relevant in the structured data side of the market. But when it comes to computer vision, unstructured content, we can use some generative techniques to support parts of the synthetic data process, but you're still fundamentally talking about using 3D simulation technologies to generate data. And that does remain hard. And part of our job is trying to make that easier for people to access.
No, thank you. So how do you see this technology evolving over the next 3 to 5 years? You've touched on how it's changed, but obviously based off of potentially, maybe you could touch on some of the lessons learned along the way that you've had, and maybe a couple of surprises that you've had along the way, like, oh wow, we didn't know we could do this, and perhaps that's going to lead to some interesting innovations coming out.
I think that one of the things maybe that just sets the table for like why we're going to see a lot more improvement in the ability to put synthetic data generation capability into more users' hands over the next few years. It's just the massive amount of data that's going to be collected and the need to extract information from that data. You've got, what is it? 100 times as many Earth observation satellites are going to be up there in 10 to 15 years. You've got centralization of everything around us, from doorbells to lights in every store that you're in, have cameras in them now, to your vehicles, to all of the equipment along transportation routes. We are sensorizing everything, and part of the reason for centralizing everything is to monitor or mostly to monitor and count things. And all that monitoring and counting is going to be done with algorithms. All of those algorithms need to be trained, and it is not possible to have all the data that is required to train those, especially for rare, unusual events. Ostriches crossing the
Well,
road in Tesla.
especially despite the amount of data that keeps on scaling up, the democratization of that data hasn't necessarily come about, and the pricing of that data is relatively maintained itself.
For sure. And human labeling of data is expensive at the end of the day, regardless of what the local, labor rates are, wherever you send that data. It is very expensive in quantity. And much of the data won't even need to be labeled, right? Your ring or Nest camera looking out from your door is going to be staring at a static scene for most of the day, and it's pointless to be having a human sit there and try to label the unusual raccoon or whatever that happens to wander by once in a while. Synthetic data allows you to generate specific scenarios, outrageous scenarios. There was a example where some U.S. military members were able to trick a robot by dressing up as trees and boxes and fooling its algorithm. Well, you know what? When they trained the algorithm on real data, and nobody thought to dress up the people in the training example as trees or boxes. That kind of absurd scenario could easily be generated with synthetic content. What we will need to do in order to make synthetic data creation more accessible to real customers is, one, we need to remember that data scientists don't want to be 3D modelers, right? Data scientists would love to use conversational AI to say, I need I need 1,000 images of this particular plane sitting on a runway in areas that look a lot like desert, or like particular snowy forest or something like that. And then in the background to have the synthetic data generation toolkit basically use that prompt to then find, source, or generate 3D models that are then assembled into a scene in the right environmental conditions and then used to generate real data. That type of of making it much easier for a user to get to the data they need without having high technical skills to do simulation or 3D modeling or programming, that is the direction that things are absolutely going to go. We have already started some work there. We're playing around with enabling synthetic data engineers, the folks who will do some of the coding on top of the simulation framework that we provide for rendered. We're right now experimenting with using ChatGPT to help kind of speed up that coding process. Once we get there, we'd actually be able to then move toward just prompt development or prompt engineering for the synthetic data channel. And it's easy to see that it's going to be possible. This company's only been around for 4 years, and so if you talk the next 3 to 5 years, it's that will be as long as Rendered's been around, and I expect things to be looking very different in the next 4 years for sure.
Awesome. As we approach closing, I want to actually present one more question to you. So, as it applies to Rendered.AI specifically, what are if a customer came to you and said, what are 3 or 4 things that I should come to Rendered for with the specific problem sets? I should come to Rendered for these reasons.
You should come to Rendered if you can't get enough of the data that you need today to train algorithms. You should come to us because we have a very good record of jumping in and helping our customers get to success. We've had some very happy customers work with us. You should also come and work with us because we are, as far as I know right now, we are the only company that has looked at synthetic data as a broad problem across computer vision and provides a platform that can handle a variety of computer vision use cases. Part of the reason for that is because we know that your computer vision problems are going to change. The things that the sensors you're using are going to change. The objects you're looking for or the classifications you're trying to make are going to change. And so you can work with us into the future to be able to use our capability and our know-how and our expert advice to help support you as your training needs, as your computer vision needs change into the future.
Awesome. Thank you. Any last minute shout outs or plugs for anything that we talked about or Render.AI specifically?
I just wanted to thank you very much, Adam, and Project Geospatial for hosting us and giving us this opportunity. It's so fun to be able to be participating in the geospatial market from a different angle, and it's been thoroughly great to see where things have gone in the last year and a half, and I'm sure that we're going to be even more relevant across the geospatial market in the future.
No, I am just as interested in, and it's amazing just sharing your story and diving into what synthetic data is and tracking Rendered through the last couple of years and seeing how you grow. I'm really fascinated to take a deep dive at some point with the data that you have and really expose how useful it is to the broader community. I think there's a huge need for it, and so I'm excited. Once again, I'm excited to share your story and share with the bigger community. So thank you very much for joining us. And we will talk to everybody next time. Don't forget, check out Rendered at Rendered.AI. And that is their website too.
Right.
So.